ये भी नहीं आ रहे। टॉप एनी डेस्क पे। ओके 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 राइट बाय। एक बार ऑडियो वीडियो चेक कर लो बेटा, आवाज क्लियर है? आवाज चेक कर लो बेटा, एक बार मुझे आवाज का कंफर्मेशन कर दीजिए। या चलो दोस्तों, वेलकम टू गेट वाला। मैं हूं सतीश कुमार, फैकल्टी ऑफ कंप्यूटर ऑर्गेनाइजेशन आर्किटेक्चर। थोड़ा सा स्मॉल टेक्निकल ग्लिच है, तो सॉरी फॉर द डिले। तो आज का सेशन मैं एड्रेसिंग मोड्स में पार्ट 2 स्टार्ट कर रहा हूं। ओके, या थैंक यू थैंक यू। चलो चलो चलो, तो आज का सेशन में एड्रेसिंग मोड्स पार्ट 2 स्टार्ट करने वाला है। इसके पहले एड्रेसिंग मोड्स, कल हमने एड्रेसिंग मोड्स पार्ट 1 डिस्कस किया है। कंप्यूटर ऑर्गेनाइजेशन एंड आर्किटेक्चर का नया पोर्शन है, नया टॉपिक्स है ईसी बच्चों के लिए। फॉर द ईसी स्टूडेंट दीज आर न्यू टॉपिक्स। पहले माइक्रो प्रोसेस माइक्रो कंट्रोलर्स था, उसके जगह में आपको क्या मिला है, अभी सीओ आ गया है, कंप्यूटर ऑर्गेनाइजेशन एंड आर्किटेक्चर आ चुका है। So if you see the syllabus of the computer organization architecture, just केवल 4 टॉपिक्स है, केवल machine instructions, addressing modes and CPU data path and pipelining। इसमें हमने 2 टॉपिक्स कंप्लीट कर चुके हैं। machine instructions बहुत ही खतरनाक का कॉन्सेप्चुअल क्वेश्चंस भी हम डिस्कस किए हैं। machine instructions के बाद then we have started yesterday addressing modes 1 and some addressing modes are pending। लास्ट क्लास में हमने नॉन कंप्यूटेशनल एड्रेसिंग मोड्स डिस्कस किया है, आज का क्लास में कंप्यूटेशनल एड्रेसिंग मोड्स डिस्कस करेंगे। ओके चलो माय डियर। ओके, एक बार जितने लोग अभी लाइव में है, थोड़ा स्मॉल डिले हो गया ड्यू टू सम स्ट्रीम की इश्यू, थोड़ा टेक्निकल ग्लिच है, सॉरी फॉर द डिले। एक बार जल्दी से जल्दी जितने लोग लाइव में है, एक बार मुझे हैश रेडी कर दीजिए एंड ट्राई टू शेयर दिस पर्टिकुलर टू योर रेगुलर स्टूडेंट्स। जल्दी से जल्दी अटेंडेंस मार्क कर दीजिए, अटेंडेंस इन द फॉर्म ऑफ द लाइक बटन and also in the form of the ready text। okay, so आज का सेशन स्टार्ट करने के पहले हम कल क्या डिस्कस किया है, these are the revision of the topics। okay, कल हमने ये एड्रेसिंग मोड्स के डिस्कशन हुए। कल हमारा एड्रेसिंग मोड्स है ये पूरा। इसमें एड्रेसिंग मोड्स में ऑलमोस्ट 2 टाइप्स ऑफ एड्रेसिंग मोड्स है, one are non computational, other one is the computational। so up to this 1 to 6 these are non computational addressing modes। क्यों नॉन कंप्यूटेशनल बोल रहा हूं मैंने, नॉन कंप्यूटेशनल क्यों बोल रहा हूं, उसमें मेमोरी का एड्रेस का कैलकुलेशन का जरूरत नहीं है, कोई मैथमेटिकल कैलकुलेशन इज नॉट नीडेड। ओके, इसमें क्या क्या कंप्लीट किया हमने, इंप्लाइड खत्म हो चुका है, इमीडिएट खत्म हो चुका है, डायरेक्ट मोड कंप्लीट कर दिया, इनडायरेक्ट कंप्लीट कर दिया, रजिस्टर मोड कंप्लीट कर दिया, रजिस्टर इनडायरेक्ट मोड भी कंप्लीट कर दिया। ओके, सो आज हमने स्टार्ट करेंगे ऑटो इंक्रीमेंट एंड ऑटो डिक्रीमेंट। इसके पहले जस्ट मैटर ऑफ 10 मिनट्स विल जस्ट रिवाइज। ओके, हाउ मेनी ऑफ यू रेडी, थैंक यू, हाउ मेनी ऑफ यू हैव डन द डीपीपी क्वेश्चंस? सम पीपल हैव पोस्टेड सम डाउट्स इन द लास्ट डीपीपी माय डियर। और डीपीपी का क्वेश्चंस भी मैं डिस्कस करने वाला हूं, अंत में डिस्कस करूंगा। डीपीपी 2 का क्वेश्चंस मैं लास्ट में मैं डिस्कस करूंगा। ओके, चलो नाउ आज फर्स्ट हमने डिस्कस करने वाला है, ये टॉपिक्स आज का टॉपिक्स है ऑटो इंक्रीमेंट ऑटो डिक्रीमेंट मोड, इंडेक्स्ड और इंडेक्स रजिस्टर मोड, पीसी रिलेटिव मोड एंड बेस रजिस्टर मोड और बेस रजिस्टर एड्रेसिंग मोड। ओके, चलो इसके पहले फर्स्ट ऑफ ऑल एड्रेसिंग मोड्स का फॉर्मेट में कुछ कंफ्यूजन होगा बच्चों को। सम ऑफ द टेक्स्ट बुक्स ऐसा देखते हैं एड्रेसिंग मोड ऑप कोड एंड एड्रेस वन, सम ऑफ द टेक्स्ट बुक्स में ऐसा होगा। सी एड्रेसिंग मोड का वे ऑफ रिप्रेजेंटेशन, द मोड के लिए कोई बिट्स होगा, सो दैट इज अ पार्ट ऑफ आप कोड इटसेल्फ एक्चुअली। ओके, सो दिस पूरा मिला के भी हम आप कोड ले सकते हैं, मोड का बिट सेपरेट का नहीं हो सकता है, ऐसा पूरा आप कोड एंड मोड मिला के भी आप कोड हो सकता है। ओके, सो दैट इज अ फॉर्मेट, आईएसए का फॉर्मेट बोलते हैं हम। इंस्ट्रक्शन सेट आर्किटेक्चर का फॉर्मेट है। एक इंस्ट्रक्शन सेट आर्किटेक्चर के लिए एक फॉर्मेट होगा, वो फॉर्मेट में मोड बिट्स आल्सो इज गोइंग टू बी क्लब्ड विद ऑपकोड बिट्स। ये पॉइंट आप नोट कर दीजिए, क्योंकि कोई बच्चे देखते हैं सम ऑफ द वेबसाइट्स और सम ऑफ द टेक्स्ट बुक्स में ऐसा है सर, सम ऑफ द टेक्स्ट बुक्स में ऐसा है। इट्स नॉट गारंटी और इट्स नॉट देयर इज अ स्टैंडर्ड रूल दैट मोड के लिए, मोड रिप्रेजेंटेशन के लिए सेपरेट बिट्स होना चाहिए, ऐसा कुछ नहीं है। देयर इज नो स्टैंडर्ड रूल, बट मोड के लिए डेफिनेटली सम बिट्स अलोकेटेड है, सो दैट कैन बी सेपरेटली लोकेटेड और दैट इज अ पार्ट ऑफ द ऑपकोड आल्सो। ओके माय डियर, चलो, सो बिफोर स्टार्टिंग, so this I want to tell you, so if you see here opcode and operand ऐसा हो सकता है, उसका डिटेल इन व्यू देखे तो opcode प्लस एड्रेसिंग मोड मिला के भी हो सकता है। मोड के लिए सेपरेट बिट्स का रिप्रेजेंटेशन इज नॉट कंपल्सरी, इट इज देयर इज नो स्टैंडर्ड रूल दैट मोड के लिए सेपरेट बिट्स होना ही है। ओके, सो जनरली डिस्प्लेसमेंट इज अ लास्ट पार्ट ऑफ द इंस्ट्रक्शन। ऑलवेज रिमेंबर द डिस्प्लेसमेंट, इसको हम बोलते हैं एड्रेस बोलते हैं, और इसको हम बोलते हैं इफेक्टिव एड्रेस बोलते हैं, जो कुछ भी हो ऑपरेंड, इट्स अ लास्ट पार्ट ऑफ द इंस्ट्रक्शन। ओके, एंड व्हाइल द अदर टू ऑक्यूपाई द इनिशियल पार्ट। इनिशियल पार्ट में क्या क्या आएगा आपको, ऑपकोड आएगा एंड एड्रेसिंग मोड आएगा। There is no hard and fast rule that the opcode and the addressing mode specifier have to be explicitly allotted bits at bit position in the instruction. This is what I want to say. There is no compulsory that opcode के लिए separate bits होना है and separate bits में represent करना है, ऐसा कुछ भी नहीं है। That's why this is an issue specific to ISCA implementation in instruction set architecture. So this is the standard, actually this is a standard instruction set architecture IS का, but there is no standard format, ऐसा ही होना है ऑपकोड प्लस एड्रेसिंग मोड, उसके बाद डिस्प्लेसमेंट, ऐसा ही नहीं है। आपको सम ऑफ द केसेस में डायरेक्टली हमने ऑपकोड एंड ऑपरेंड को भी देख सकते। ओके, कल हमारा पूरा एक्सप्लेनेशन ऑपकोड एंड ऑपरेंड से हो गया, आज लेट अस सी लाइक दिस। ओके, सो नाउ इफ यू सी द इम्प्लाइड एड्रेसिंग मोड, देखो ऐसा ISA का फॉर्मेट है। This is what we call, this is the ISCA format, okay ना, इंस्ट्रक्शन सेट आर्किटेक्चर का फॉर्मेट है। उसमें हमको क्या दिखा रहे, ऑपकोड एंड मोड। so that means what this mode represents, what is the type of the mode। अगर immediate मोड है, फटाफट कर देंगे, अगर immediate मोड है क्या होगा, immediate मोड है तो immediately एड्रेस फील्ड में क्या होगा, ये ऑपरेशन एड्रेस का जरूरत नहीं है एंड ऑपकोड इटसेल्फ विल रिप्रेजेंट द ऑपरेशन। ओके, ऑपरेशन एंड ऑपरेंड एवरीथिंग विल बी इन द ऑपकोड। मैंने एग्जांपल भी दिया आपको, एग्जांपल है CMA कॉम्प्लीमेंट अक्यूमुलेटर, इसमें ऑपरेंड्स का फील्ड ही नहीं है। ओके ना, एंड नेक्स्ट आई कैन टेक इट एज क्लियर कैरी। ओके ना, आई कैन टेक इट एज एनेबल इंटरप्ट, दीज आर द स्टैंडर्ड। ओके ना, आई कैन टेक इट एज सेट कैरी, और आई कैन टेक इट एज रोटेट लेफ्ट, RLC, rotate left through carry. Okay, so rotate right ROR. So these are certain instructions, these are certain instruction, इसमें हमने ऑपरेंड का जरूरत ही नहीं है। ओके माय डियर, चलो सचिन कुमार यादव, या लास्ट क्लासेस देख लिया आपने, DPP अटेम्प्ट किया। जितने लोग लाइव में हैं मुझे एक बार थम्स अप दिखाइए बेटा, एंड प्लीज ट्राई टू गिव योर अटेंडेंस। ओके, try to give attendance in the form of liking the button, सेशन को लाइक करो एंड डेफिनेटली DPP को अटेम्प्ट करने की कोशिश करो। सेशन पूरा देखने के बाद DPP को अटेम्प्ट करने की कोशिश करो। हैव यू अटेम्प्टेड, एनीबडी अटेम्प्टेड द DPP हियर, प्लीज टेल मी। एनीबडी इज हैविंग द डाउट्स इन द DPP, दैट आल्सो प्लीज टेल मी। भावेश एंड सचिन, वेरी गुड वेरी गुड। चलो, DPP में कल मैंने देखा यूट्यूब में कुछ डाउट्स पोस्ट कर दिया, वो डाउट्स मैं अंत में एक्सप्लेन करता हूं, एंड ऑफ द सेशन में विल एक्सप्लेन। चलो नेक्स्ट विल गो फॉर इमीडिएट एड्रेसिंग मोड। इमीडिएट एड्रेसिंग मोड में क्या होगा, ऑपकोड एंड ये मोड इज द रिप्रेजेंटेशन, दिस इज द रिप्रेजेंटेशन ऑफ इमीडिएट। एड्रेस फील्ड में क्या होगा, एड्रेस फील्ड में डायरेक्टली ऑपरेंड हो सकता है। So the best example I have given yesterday, the best example I have given as move immediate a comma sum 22. So this is the opcode, my dear, and this is the operand. Operand is directly a number. Operand is mostly a number, my dear. No sir, this is my first class. Okay, no issues. थोड़ा फास्ट में ट्राई टू अंडरस्टैंड दिस एड्रेसिंग मोड्स. आप ईसी बच्चे है तो आपने ईसी में माइक्रो प्रोसेसर में पढ़ चुके हो ऑलरेडी. यू कुड हैव स्टडीड माइक्रो प्रोसेसर. इन द माइक्रो प्रोसेसर हैविंग सम एड्रेसिंग मोड्स. ओके, लेकिन हियर सीओ में क्या करते हैं ना, स्पेसिफिक टू माइक्रो प्रोसेसर नहीं पढ़ते हम. वी आर नॉट गोइंग टू बी वेरी स्पेसिफिक टू माइक्रो प्रोसेसर. वी आर गोइंग टू बी ए जनरलाइज्ड. That means computer organization architecture completely discusses about the generalized. It's not specific to any particular microprocessor. चलो next, direct or absolute. Direct addressing mode में क्या होगा? So this is the direct mode representation. The mode of addressing is direct. And address में क्या होगा? Address में आपको effective address होगा. So that effective address we have to search in the memory. Then we are going to get the operand. Operand directly instruction में नहीं होगा. So for example, if I am writing a instruction like this, LDA load accumulator, okay, this is an instruction, and we are writing suppose 200. So 200 is a memory location. So if we go to the 200 memory location, in the 200 memory location we have an operand called 22. So this is the 200 memory location. So the processor has to go for the search of the memory. The address bus has to go for the search of the memory. ओके टू एस. कंप्यूटर साइंस से तो भी नो प्रॉब्लम, आपका ये सेशन यूजफुल होगा. सीएससी लोगों के लिए बहुत अच्छा यूजफुल होगा क्योंकि सीएससी पीपल को बहुत ज्यादा वेटेज है कंप्यूटर ऑर्गेनाइजेशन का. सो द बेस्ट एग्जांपल इज सपोज दिस इज व्हाट लोड अक्यूमुलेटर. डिफरेंट माइक्रो प्रोसेस में ये सिंटैक्स अलग रहता है. सो दिस इज लोड अक्यूमुलेटर बाय द कंटेंट्स ऑफ effective address 200. So this 200 is what we call as effective address beta. So this is the effective address. वो effective address में हमको operand मिलेगा. So this is what we call direct addressing mode. समझ में आपको? Everybody understanding? These all we have discussed yesterday. Next, indirect addressing mode में क्या है? Indirect addressing mode में हमने directly हम indirect addressing mode में क्या कर रहे हैं? 2 times we have to go. Okay. So for example, if I am going for this particular address, that means if I am writing like this. So for example, if I am writing like this, suppose if I am writing suppose if I am writing like this, move A, comma 0100. This is direct and this is indirect. That means what? 0100 is a effective address. And if we go to the 0100, this particular location, this 0100 contains again a effective address 0200. Okay, so that 0200 is suppose somewhere here. That means this is somewhere here. So here you are having an operand 44. That means this is first time you are accessing the memory, and this again second time you are accessing the memory. 2 times आपको जाने का तैयार है. That means इंस्ट्रक्शन में एड्रेस फील्ड में जो कुछ है वो ऑपरेंड नहीं है, वो इफेक्टिव एड्रेस है. अगर वो इफेक्टिव एड्रेस को जाए तो और एक इफेक्टिव एड्रेस मिलेगा. सो वही इफेक्टिव एड्रेस में आपको ऑपरेंड मिलेगा. डू अंडरस्टैंड दिस लॉजिक? सो दिस इज व्हाट वी कॉल एज इनडायरेक्ट एड्रेसिंग मोड. समटाइम्स दिस इनडायरेक्ट एड्रेसिंग मोड हमको रजिस्टर के फॉर्मेट में भी हो सकता है. रजिस्टर इनडायरेक्ट बोलते हैं. ओके, सो दैट आल्सो वी हैव डिस्कस्ड इन द लास्ट क्लास. Next one is the register addressing mode. Register addressing mode is very simple, my dear. Register addressing mode is very simple. I am going to write add a comma b. So here there is no question of memory access. In register addressing mode there is no question of memory access. So I can write directly move a comma suppose c. So in this there is no question of memory access. So registers itself are presented in that. So in the address field we are having the register. Operands are present in the register, my dear. Next comes register indirect. In the register indirect क्या बोलते हैं? So हमारा address के field में effective address is present in the form of register. That register, for example, if I am taking a register called, suppose if I am taking a register called SI, or if I am taking any register, source index register, suppose in microprocessor one register called source index. So this particular register, or अगर आपने CSC background है, so you can take the register R. ओके, ये रजिस्टर में क्या मिलेगा आपको? इफेक्टिव एड्रेस मिलेगा. सो दिस रजिस्टर कंटेन्स 100. So if you go to that 100, you are going to have the operand. Okay, so mode is used to shorten instruction length. One register and one memory access is required only once you are going. The best example I will tell you here, suppose if I am writing the instruction like this. So if I am writing the instruction in microprocessor language, if I am writing the instruction like this, move AL comma within the square brackets SI. So these are register indirect. SI is a source index, but SI contains what? SI contains effective address 100. So if you go to that 100, you are going to get the operand. Okay, so SI is 100. So you are expressing the effective address in the form of a register. समझ गया आपको? All of you understanding, my dear? Yeah. So this is what we call register indirect. Next comes most important. आज का सेशन है ऑटो इंक्रीमेंट एंड ऑटो डिक्रीमेंट. तो ये पर्टिकुलर एड्रेसिंग मोड का नाम से ही आपको याद में होना है, आपको जस्ट सम बेसिक आइडिया हो सकता है. क्या आइडिया? समथिंग इज गोइंग टू बी इंक्रीमेंट ऑटोमेटिकली, समथिंग इज गोइंग टू बी डिक्रीमेंट ऑटोमेटिकली. आई एम राइट और नॉट? यस. क्या है देखो, हियर दिस इज अनदर फॉर्म ऑफ रजिस्टर इनडायरेक्ट. रजिस्टर इनडायरेक्ट का अदर फॉर्म है, लेकिन इधर क्या है ना, वो जो कुछ रजिस्टर है ना, द रजिस्टर इज गोइंग टू बी ऑटोमेटिकली इंक्रीमेंट आफ्टर एवरी ट्रांजैक्शन or automatically decrement. See, for example, if I am taking opcode mode address, the address field is related to some register. The register is suppose R. In that register we have a 100. So if you go to the 100, you are going to get an operand. This is the 100. Okay na my dear? And after taking that operand, kya hoga? This particular register will be automatically incremented. It is automatically incremented and it will become as 101. So now it will move to the next operand 2. Like that, जो कुछ ऑपरेशन आप करना चाहते हो ये ऑपरेंड्स पर, अगर आपने कॉमन ऑपरेशन करना चाहते हो ऑपरेंड्स के ऊपर, फॉर एग्जांपल हियर आई एम हैविंग 2, यू आर हैविंग 3, यू आर हैविंग 4, एवरी ऑपरेंड को मैं एक सम्मेशन करना चाहता हूं. सपोज यू आर हैविंग ऑपरेंड 1 हियर समथिंग, सपोज नंबर सम 20, so here I am having operand 21. So if I want to add +5, if I want to add +5, like that, just like in our C language we have a array. ओके ना, अरे में जो कुछ एलिमेंट्स है वो एलिमेंट्स के ऊपर मैंने कुछ मल्टीप्लिकेशन करना चाहता हूं और कुछ समेशन करना चाहता हूं. उसी समय क्या क्या बार बार ये पर्टिकुलर इफेक्टिव एड्रेस को एक्सेस करने की जरूरत नहीं है. ऑटोमेटिकली अगर ऑपरेंड 1 लिया उसके बाद ऑटोमेटिकली क्या होगा, रजिस्टर विल बी इंक्रीमेंट. ओके, सो दिस रजिस्टर विल बी गोइंग ऑन इंक्रीमेंटेड ऑटोमेटिकली. माय डियर, समझ गए आपको? ऑल ऑफ यू अंडरस्टूड माय डियर? जितने लोग सेशन को देख रहे आपका रिस्पॉन्स दीजिए बेटा, क्योंकि अगर ये सेशन अंडरस्टैंड करे तो आपको डेफिनेटली प्रॉब्लम सॉल्व करने का प्रैक्टिस ज्यादा होगा. क्योंकि इफ विदाउट अंडरस्टैंडिंग दिस यू कैन नॉट गो फॉर द न्यूमेरिकल सेशन. डू यू अंडरस्टैंड दिस और नॉट? After every iteration, this particular register is going to be automatically increment 101. Then it will go to the next operand. Next, the register becomes 102. The register becomes 102. The register becomes 103. Like that, the register goes on incrementing. जो कुछ आप एड्रेस में रजिस्टर है ना, वो रजिस्टर goes on incrementing automatically. My dear, क्लियर है? चल, बेस्ट एग्जांपल मैं बताता हूं आपको. एक बेस्ट एग्जांपल मैं बताता हूं. सी हियर, जितने लोग इधर माइक्रोप्रोसेसर का कुछ आइडिया है मैं उसको बताता हूं. देखो, ध्यान से देखो. So this is my memory, my dear. This is a list. Okay na? So this is a list. Suppose this list is having certain memory address 0100. This is 0101, 0102, 0103, like this. Okay. So एक simple example मैं बोलना चाहता हूं. For example, I have taken a SI register, source index register. What is this name? SI, source index register. ये source index का वैल्यू है 0100. कितना है? 0100. ओके, गॉट इट? कोई रजिस्टर, सपोज यू कैन टेक एनी रजिस्टर. लेट अस टेक द रजिस्टर, सपोज CSC बैकग्राउंड. सो द रजिस्टर इज R1. क्या है रजिस्टर? R1. रजिस्टर है 0100. So that 0100 is related to certain memory location. So this is a memory location. Let us take 0100 is a memory location. A 0100 में I have a number called 1. Next comes the memory location. I don't know that 2, 3, like this. So now what I want to do, I want to perform certain operation on it. Okay. So I want to perform certain operation on it. What is that operation? I want to increment each and every element in this particular array. So what I will do now, suppose if I am taking move a comma, this is a register indirect addressing mode. Can I write like this? Can I write like this or not? Deepa, are you following? Ankit Singh, are you following? क्योंकि जनरलाइज्ड फॉर्मेट में एक्सप्लेन करना बहुत दिक्कत है. Try to understand. So अभी what is the accumulator value, my dear? See, this is increment A. Okay, so this is increment A. Suppose when I say increment A, what happens now? Increment it and post it here. Then what happens? This will become +1. By the time it completed, if you just jump back, okay. So if you go to the back, what happens now? This register will be automatically incremented. Now it points to 0 1 0 1 0 1 0 1. Increment A. So what is that location now? Increment that particular R1. See what I mean to say. This time it is going to get the 2 plus 1 hoga. Jump back, it is going to be incremented. So like this, it is auto increment process is going to happen. अगर आपने 8085 और 8086 माइक्रो प्रोसेसर पढ़े तो आपको ये बहुत इजी होगा, बहुत इजी होने की चांसेस है. क्लियर? चलो नेक्स्ट आज का मोस्ट इंपॉर्टेंट है इंडेक्स्ड और इंडेक्स रजिस्टर एड्रेसिंग मोड. दिस इज समवॉट रिलेटेड टू योर सी लैंग्वेज. ओके, इन सी लैंग्वेज अगर आपके पास फॉर लूप है, फॉर i is equal to 0, i less than 50, i plus plus like that है. Okay, so here what I want to do, consider a particular array. Let us talk in terms of C language. Consider a particular array. So this array of integers, this array name is A and it is having 5 elements. 1, 2, 3, 4, 5 elements. So what is the size of the array? Size of the array is 5 elements. And internally it contains each element. The size of each element is, the size of element, let us take 2. Kitna hai size of element? 2 bits. Okay, or size of element is 2 bytes. Okay, so now what happens? See, now I want to access a particular memory location. So the base address here is, see here, the base address is suppose 100. So in this, the base address kitna hai, my dear? The base address is 100. Okay, so now I want to go for array of 3. Array of 3 means kaha hai array of 3? This is the 3. Why? Because array of 0 requires how many memory location? 2 memory location. Yes or not? So next one requires 2 memory location. Yes or not? So what I have to do now? I want to access the third array element. So what to do now? 100 को किस add करना है? Third element 106 है. So 106 कैसे add करना? So size of each element is what? Size of each element is what? 2 na? Each array element takes 2 locations. Okay na? So if I want to access array of 3, so what I have to get now? This is 100 plus what is that size into 2. So how far it is a distance? This is at a distance of how much, my dear? From 0 से ये कितना distance में है? Third है ना? So 2 into 3, so पूरा मिला के कितना होगा? 106 होगा. Do you understand, my dear? So here this particular W into 3 है ना? All of you following my point? This W is what? Size, and 3 is your position. I want to move to the array of 3. These are 5 elements. I want to move to the position 3. So this particular 2 into 3 को हम बोलते हैं index बोलते हैं. क्या बोलते हैं उसको? Index. Do you understand? This is going to be represented in an index. So now what is the effective address calculation, my dear? Effective address is equal to base address plus index. Do you understand, dear? All of you followed or not? Please tell me your response. Base address is equal to what? Base address क्या होगा? Sorry, effective address क्या होगा, my dear? Effective address is equal to base address plus index होगा. So what is the index? Index is represented as the size of the element and your location, whatever the location you want to access. See here. Suppose The same thing I have given a in-depth explanation here. Chalo. So what is the way of representation here? So this is our address. For the address we are adding the index. This index is going to be stored in a register, my dear. This index is going to be stored in a register. So base address plus this is the from this side we are getting the base address, and this side we are getting the index. So base address plus index register. बेस एड्रेस प्लस इंडेक्स रजिस्टर पूरा मिला को आपको इफेक्टिव एड्रेस मिलेगा. इन दैट इफेक्टिव एड्रेस आपको ऑपरेंड मिलेगा. All of you are following, dear? All of you are following or not? Deepa, Huja, following? Everybody, please respond yourself. इंडेक्स कहाँ होगा? इंडेक्स के लिए एक सेपरेट रजिस्टर होगा, वो रजिस्टर में वैल्यू रहेगा. जस्ट लाइक सोर्स इंडेक्स, डेस्टिनेशन इंडेक्स का वैल्यू होगा, वहां से आएगा. प्लीज रेस्पॉन्ड. I need a response, my dear. All of you are following or not? For example, this is the meaning. Move AL, okay na? Move AL. I'm having an effective address 100 and again SI. That means what? This is the base address 100 and SI is having some number. O address be add karo. So everything is added and that is going to come here. Got it? Now, the next one and the last one is the PC relative addressing mode, my dear. PC relative addressing mode is actually used to move from one location to other location. ये कैसे अंडरस्टैंड करना है, मैं एक एग्जांपल से बताता हूं इसमें. फॉर एग्जांपल, यू टेक सर्टेन सेट ऑफ इंस्ट्रक्शंस. सपोज दिस अ प्रोग्राम. दिस प्रोग्राम इज स्टार्टिंग सपोज फ्रॉम 100. This program is starting from 100. So here I am having some instruction 1. Okay na? And again this 102. Suppose let us take each instruction is taking 2 bytes. So here suppose I have 101 or 101 instruction 2. Suppose instruction 2 like this. 102 instruction 3. 104 103 instruction 4. Like that. Suppose here a 205 instruction, suppose some other instruction called some 1/10 or 5th any number of instructions. This is IN instruction, and next here 206 IN plus 1. Suppose in the sequence of executing this instruction, first instruction you are executing, my dear. Processor is executing the first instruction. When the processor is executing the first instruction, what is the PC value? Can anybody tell me? If the processor is executing this first instruction, what is the PC value? All of you. PC represents what? Address of the next instruction to be executed, my dear. PC represents address of the next instruction. So I need the value of PC. Can anybody type me? What is the PC value here? PC का value कितना होगा? If the processor is executing the instruction 1, PC का value कितना होगा? PC represents what? PC represents the program counter. So program counter का value होगा 101. For example, in this 101, suppose instruction 2 है ना? So now you went for instruction 2. Okay? So when you are handling the instruction 2, then what is the PC value? Okay, 102. But the problem here is the instruction 2 is a jump instruction. Okay na, it is a branch instruction. Jump to, suppose 205 is there. What is there? Jump to 205 is there. Do you understand? Who knows? The processor पहले ही आप डिटेक्ट नहीं करते, वो branch instruction है, non branch instruction है, और conditional भी हो सकता है. For example, there is one instruction called JNZ. JNZ, suppose 205. Suppose some condition. So suppose if the condition is false or the condition is true, क्या होगा? इफ द कंडीशन इज ट्रू, इफ द कंडीशन इज फॉल्स क्या होगा माय डियर, जल्दी से बताइए। अगर कंडीशन ट्रू है तो कहां जाना है, पीसी शुड बी हाउ मच नाउ, एंड द कंडीशन इज फॉल्स, पीसी शुड बी हाउ मच, प्लीज टेल मी। सी when you are executing the first instruction, PC का वैल्यू पहले 100 था, before the programming starts PC का वैल्यू 100, then you have started the instruction execution. When executing instruction 1, PC value updated to 101, you went to instruction 2, and when you are executing the instruction 2, the instruction 2 is this instruction. This instruction is having some condition test. अगर एक condition सही है तो कहां जाना है, जल्दी बताइए दीपा, please try to understand and tell me. If a condition is true, this is a true or false condition. Jump if not 0. If condition is true, then कहां जाना है। सेशन को लाइक करके जाओ, सेशन को रिस्पॉन्ड करते जाओ। थोड़ा सा दिक्कत है सीएससी पीपल को, क्योंकि ये सब्जेक्ट सीओए एंड ईसी पीपल को, सीएससी पीपल को अंडरस्टैंड करने में थोड़ा अंतर है, क्योंकि ईसी पीपल को माइक्रो प्रोसेसर को परिचय है, सीएससी पीपल को माइक्रो प्रोसेसर से कम परिचय। टेल मी व्हाट इज द पीसी वैल्यू, जल्दी बताइए भैया, पीसी वैल्यू क्या होगा। वेरी गुड। इफ कंडीशन इज ट्रू कहां जाना है, इफ द कंडीशन इज ट्रू वेयर टू गो, कंडीशन इज ट्रू माय डियर, जंप इफ नॉट 0 205, कंडीशन इज ट्रू मींस पीसी वैल्यू हैज टू बी अपडेटेड टू 205. Got it? If the condition is false, it has to go to the next instruction. The next instruction starts at 103. Am I right or not, my dear? Am I right or not, my dear? Not 206, my dear, 205. The next instruction is at 205. Why? Because I have mentioned this address. So this address is what? 205. 205 को jump करना है. Yes or not? 205 को जाना है. That means what? From 102 you have to move to 205. Am I right or not? 102 से 205 को जाना है. That means 102 को कितना ऐड करना है, 103 ऐड करना है, 103 ऐड करना है. So this is what we call as relative address, my dear. क्या बोलते हैं उसको? इसको हम क्या बोलते हैं? Relative address बोलते हैं. Do you understand? Is it clear, Deepa? It's not 206, 205. When condition is true, you have to move to 205. In the 205, the branch instruction is there. Got it or not? So here the relative address क्या है? PC के बाद कितना distance से आपका instruction है. So this 103 is the relative address. 102 को 103 add करें तो आपको 205 आएगा. Am I right or not? So this is what we call as PC relative address. That means what I am going to do here. See here. The PC contains how much? Some 102. So this PC contains how much? 102. And what is the address we are connecting here? This is the address. So this address will be how much? 103. So 102 plus 103 कितना हो गया? 205. अगर 205 को जाए तो आपको क्या मिलेगा? आपको ऑपरेंड नहीं मिलेगा माय डियर, आपको ऑपरेंड नहीं मिलेगा. रिमेंबर दिस लॉजिक. अगर 205 को गए तो आपको क्या मिल रहा है? आपको ऑपरेंड मिल रहे हैं? नहीं. 205 लोकेशन में आपको इंस्ट्रक्शन मिलेगा. सो दैट इज द ब्यूटी ऑफ, दैट इज द डिफरेंस ऑफ पीसी रिलेटिव एड्रेसिंग मोड. पीसी रिलेटिव एड्रेसिंग मोड्स में अंत में क्या मिलेगा आपको? इफेक्टिव एड्रेस में. रिमेनिंग ऑल एड्रेसिंग मोड्स में इफेक्टिव एड्रेस में क्या मिल रहा है आपको? ऑपरेंड मिल रहा है. लेकिन यहां इफेक्टिव एड्रेस में क्या मिल रहा है आपको? आपको ब्रांच इंस्ट्रक्शन मिल रहा है. प्लीज मेक ए नोट ऑफ दिस पॉइंट. प्लीज मेक ए नोट ऑफ दिस पॉइंट माय डियर. Except PC relative addressing modes, remaining all addressing modes, you are going to get at the end of the effective address calculation, you are going to get the operand. लेकिन यहाँ instruction मिल रहा है. Okay, my dear, all of you followed? Is it clear, my dear? Up to now, is it clear? See, everybody, जितने लोग अभी सेशन में देख रहे हैं, 16 पीपल आर वाचिंग. आई नीड द 16 पीपल का थंब सिंबल चाहिए, क्योंकि अभी मैं एक अच्छा एग्जांपल से 16 पीपल आर वाचिंग दिस सेशन. 16 पीपल को मैं अभी असाइनमेंट दे रहा हूं. जितने लोग अभी सेशन को दे रहे हैं, प्लीज टाइप योर ब्रांच नेम. Out of the 16 students, everybody whoever watching this session, please type your branch name. लेकिन अभी मैं क्वेश्चन को चूज कर रहा हूं, इसलिए मुझे एक काउंट चाहिए. जितने लोग क्लास में हैं, जितने सेशन अभी लाइव में है, 16 people are watching. I want to know how many of you are from ECE, how many of you are from CSC, or how many of you are from instrumentation. I need the branch name, ECE or CSC, because now the topic that I am going to start, is most important, understandable topic both for ECE and sometimes CSC people को दिक्कत होगा क्योंकि ECE people का understanding अलग है. That's why. ESC, very good. 2. Next. ECE, next. Nice. Nice. Why? Because ECE people को ये जो कुछ topic मैं अभी बोल रहा हूँ, this topic is very, very understandable topic. I think all of you know addressing modes का topic in 8085 microprocessor. Have you studied this? Addressing modes of 8085. How many of you studied? Addressing modes of 8085 microprocessors. How many of you studied, my dear? I think आपका BTech ECE में 8085 microprocessor पढ़ चुका है. Yes or not? 8085 microprocessor पढ़ चुका है. 8085 microprocessor supports how many addressing modes? 8085 microprocessor supports only some addressing mode. The first addressing mode is the immediate addressing mode, my dear. So if you see the immediate mode, the immediate addressing mode in 8085 microprocessor will be like this. Move immediate I होगा, immediate addressing mode का नंबर ऐसा होगा, move immediate A, 22. Okay, so if you see with respect to memory, फटाफट. Why? Because this is exclusively for EC people. अगर CSC people को understand करे तो भी अच्छा है, क्योंकि this is the actual addressing mode का application. CO में हम addressing mode का architecture के बारे में discuss करते हैं, उसका implementation processor पे होता है. So if you see the memory, my dear, so this is the opcode memory and this is our opcode. See, the first one is the opcode, my dear. For example, this starts from a memory. So this the move immediate A is the opcode and next comes the operand, my dear. So this is a 2-byte instruction. So let us take this a memory address location. Suppose 0100 is starting address and 0101 is nothing but operand. So this comma के बाद जो कुछ है, so this is what we call, my dear, operand. So operand itself is a directly immediate number. ये immediate addressing mode ये नहीं, that is based upon this I. अगर instruction में I है तो वो immediate addressing mode है. Similarly, I think all of you know this LXI B 1 2 3 4. Can you tell me what is this the meaning of this? Please tell me. EC बच्चों, LXI B 1 2 3 4 means what? LXI B 1 2 3 4 means what? Here load immediately, but here X है, B is a register, my dear. So B is a register, but we have to take a pair register, my dear. So we have to take a pair register. The pair for the B is what? The pair for the B is C, my dear. Yes or not? The pair for the B register is the lower will go to the lower memory location, higher will go to the higher memory location, my dear. 1 2 3 4. Am I right or not? Shashank, Balaji, is it clear? Yes, register pair में 1 2 3 4 ऐसा आएगा. Lower will go to the lower, higher will go to the higher. Am I right? चलो, this is 8085 microprocessor. Got it? The same thing if I am representing in 8086 microprocessor. Okay, first we'll cover the 8085 microprocessor, then we'll go for the other. I think all of you are following. Chalo. Second, I am going for register addressing mode. Register addressing mode. In register addressing mode, both are going to be registers. Simply add A, comma B. Okay, na? So we can write like this: add A, comma B, PCHL. So these all are register addressing modes. So what is the meaning of this? Contents of the B are contents of the B are added to the contents of the A and the result is going to be stored in A. That is the meaning of it. PCHL means what? the contents of the HL are copied to PC. That's it. So it is a register addressing mode. All of you understood, my dear? So this is a register addressing mode. Next comes the direct addressing mode, my dear. The next one is the direct addressing mode. I think all of you are following now. It is very easy now to understand because जो कुछ मैंने CO में पढ़ाया अभी मैं अप्लाई कर रहा हूं मैं माइक्रो प्रोसेसर को. I think all of you are following. डायरेक्ट एड्रेसिंग मोड में क्या है, डायरेक्टली हमने एड्रेस देते हैं लोड अक्यूमुलेटर 2000H. That means what? There is a particular memory location, my dear, like this. Okay, so in this there is a memory location called 2000H. In 2000 there is a number called 44. So this 44 is going to be loaded into the accumulator, my dear. Similarly, there is one more instruction called store accumulator. Store accumulator 4000H means accumulator में जो कुछ content है, so that is going to be copied to 4000H memory location. Okay, my dear. So this is going to be 44. So this is what we call load accumulator and store accumulator. I think all of you are following now. So this is the load accumulator instruction. This is a store accumulator instruction. मजा आ रहा है? Everybody is following, my dear. जितने लोग सेशन को देख रहे EC बच्चे हो, आप कनेक्ट होना है यार. EC people must be connected here. चलो next number 4. Suppose if I am taking number 4, register indirect. Number 4 is register indirect addressing mode. Register indirect addressing mode में क्या होगा? For example, if you take the register indirect addressing mode LXI H 2500 and we are writing the instruction like this, move A comma M. How many of you understood this particular point? How many of you understood this logic? Or I can write like this, LXI B comma 2500. Okay, so that means what? B and C are going to become 2500 and move A comma B, move A comma, suppose sorry if I take the H, that is only correct. So if I am taking H here and if I am writing M, what is the meaning of this? HL register pair. So this is a HL register pair, my dear. So this is a H and this is a L. So this is going to become 25, this is going to become 00. And now if you take the memory location, this is a high, this is a low. So this is the memory location of 2500. This is the memory location of 2500. In the 2500, whatever the content is there, that content is going to be loaded into the accumulator. Am I right or not? Am I right or not? Are you following? Yes. Load into register pair. X represents pair, my dear. X means pair. Always remember, X means pair. X means pair. So H ka proper pair is L. B ka proper pair is C. D ka proper pair is E. In 8085, we have the registers like this. This is A and B is paired with C. D is paired with E. H is paired with L. Individually 8 bit है, collectively 16 bit है. This is the best way. You understand, my dear? All of you are following, my dear? Deepa, are you following? Vinay Pratap, are you following? Shashank Balaji, are you following? This is most understandable way. Why? Because when you study an architecture point of view, you cannot understand. That particular architecture, ऐसा register addressing mode ऐसा होना है. See, रजिस्टर इनडायरेक्ट एड्रेसिंग मोड बोले तो इसका पीछे मैकेनिज्म कैसा होना है, दैट इज ऑल आर्किटेक्चर, यू अंडरस्टैंड, एंड हाउ इट इज गोइंग टू बी इंप्लीमेंटेड, दैट इज कॉल्ड ऑर्गेनाइजेशन. ऑल ऑफ अंडरस्टैंडिंग. सपोज हाउ दिस इज हैपनिंग सर, सर इसके पीछे मैकेनिज्म क्या है, व्हाट मैकेनिज्म है, दैट इज आर्किटेक्चर. हाउ इट इज इंप्लीमेंटेड, दैट इज ऑर्गेनाइजेशन. दैट्स इट. एंड द लास्ट वन इज द implied addressing mode. So last one is the implied addressing mode. Implied addressing mode बोलो तो no operands, simply no operands, no operands. So what are the instructions my dear? Examples बताइए. Here we are having instruction like complement accumulator. Accumulator is going to become complemented accumulator. मजा आ गया. So 8085 supports how many addressing modes? 8085 supports 5 addressing modes my dear. 8085 supports how many addressing modes? 5 addressing mode. The first one is the immediate, second one is the register immediate mode, second one is the register mode, third one is the direct mode addressing mode, fourth one is the register indirect addressing mode, and the fifth one is the implied mode. Please make a note. Up to now we didn't get any question in the CO paper. My dear aspirants of ECE, in the last year I didn't find any question on the COA paper. For ECE people, we didn't have any COA paper. Do you have any questions with you? No. GATE exam में last year CO पर कुछ questions नहीं आया, लेकिन COA subject is replaced under the microprocessor and he has given addressing mode. Addressing modes in a common format. अभी समझ में आपको? All of you understood my dear? Please सेशन को रेस्पॉन्स दीजिए बेटा, क्योंकि बहुत दिक्कत है. COA सब्जेक्ट EC पीपल को अंडरस्टैंड करना बहुत दिक्कत है. कंप्यूटर साइंस के लिए अलग फॉर्मेट है, EC पीपल के लिए अलग फॉर्मेट है. ज्यादा माइक्रो प्रोसेसर के एंटर नहीं होना, ज्यादा CO के भी एंटर नहीं होना, मिडिल पाथ में जाना है EC बच्चों के लिए, क्योंकि ये कंप्यूटर साइंस बैकग्राउंड सब्जेक्ट है. मजा आ गया? आई होप CSC पीपल आर ऑल्सो फॉलोइंग. फारूक नहीं, ओके. I hope CSC people are also following. Yeah, question नहीं आया. Last time we didn't get any question. CSC people are you following? अगर आपको CSC को 8085 कुछ आइडिया है तो now I think you have connected the register indirect is connected or not? Yes. Implied is connected or not? इतना easy से understand direct addressing mode बोला तो address directly mention दिया है, directly address दिया है. तो once again in brief मैं बोल रहा हूँ, immediate addressing mode में operand is directly data. Next. Register addressing mode में both are operands or registers. Direct addressing mode में address field is effective address directly given. Register indirect address में effective address is mentioned indirectly. What is that indirectly? M points to what my dear? This M points to memory. What is that memory? That memory is this 2500. This is a memory location, but the memory is pointed not directly. Memory is pointed indirectly with the register pair HL. Got it? चलो next last one implied addressing mode. अब तक मजा आ गया? चलो सम्राट. Okay. चलो now let us go for interestingly, my dear ECE students, 8085 is a 8-bit microprocessor. Am I right? 8085 is a 8-bit microprocessor. That means जो कुछ अरिथमेटिक ऑपरेशंस वो करता है केवल 8 बिट पर लिमिटेड है. अगर माइक्रोप्रोसेसर का एक्सटेंशन हो गया 8086 माइक्रोप्रोसेसर, देखो 8086 माइक्रोप्रोसेसर में कितना एड्रेसिंग मोड्स है? The 8086 microprocessor addressing modes are different, my dear. 8086 addressing modes are entirely different. As the processor architecture is 16-bit architecture now. As a 60, okay, no problem. MCA स्टूडेंट भी आप पढ़ा सकते हैं, MCA स्टूडेंट्स को भी CO सब्जेक्ट है. As a 8086 is a 16-bit architecture, इसको more addressing modes होगा. Have you observed? In 8085 we didn't find index addressing mode. In 8085 we didn't find PC relative addressing mode. In 8085 we didn't find auto increment decrement addressing modes. Yes or no? But if you see the 8086, the 8086 first addressing mode is immediate addressing mode, my dear. Please note down fast. 8086 में first addressing mode क्या है? Immediate addressing mode है. In immediate addressing mode, 8086 is a 16-bit. तो एग्जाम्पल डायरेक्टली मैं दे रहा हूं आपको इंस्ट्रक्शन के फॉर्मेट में, मूव AX, 1 2 3 4 H. इसका मतलब है the accumulator is 16-bit, so this is our AL, this is our AH, so this is the 34, this is the 12. Accumulator low, accumulator high. It is a 16-bit registers. Okay na my dear? All of you following? Chalo. Immediately number diya maine. So that is the beauty of 8086. Second, we'll go for register mode. If you go for the register mode, I think all of you are able to see. Yeah. In register mode, both are registers, my dear. Add AX, BX. Add AL, BL. This is a 8-bit addition. This is a 16-bit addition. Perfect. Are you following ECE students? I hope ECE students अभी खुशी होगा. ECE बच्चों अब खुश होगा क्योंकि सर हमको ECE का जो कुछ कंटेंट अभी दिख रहा है. सर कल तक हमने पूरा कंप्यूटर साइंस का वर्ड सर यू आर यूजिंग सर, हमको ये क्या है, पीसी रिलेटिव क्या है, ये वॉन न्यूमन क्या है, ओके, ये डाटा पाथ क्या है, ये मशीन इंस्ट्रक्शन क्या है, आप कोड क्या है, ऐसा कंफ्यूजन में होगा. लेकिन आज आपका जो कुछ एड्रेसिंग मोड्स व्हेन यू आर अप्लाइंग टू द प्रोसेसर लेवल, आई थिंक ऑल ऑफ यू आर फॉलोइंग. क्लियर? बोथ आर रजिस्टर्स. नेक्स्ट नंबर 3, आई एम गोइंग फॉर द नंबर 3 माय डियर. I'm going for number 3. Listen, number 3 is direct addressing mode. Direct addressing mode, my dear. In direct mode क्या होगा? Listen carefully. How to represent the direct addressing mode here? Move AL within the square brackets 0100. Am I right or not? Am I right or not? Directly effective address. Yes or not? Good evening Nandesh Krishna, good evening. AX क्या है? सम्राट जी अगर आप MC है तो मैं क्या बोल रहा हूं, AX is a accumulator 16-bit. अगर 16-bit है तो उसमें दो 8-bit का कंटेंट होगा, AL and AH. 16-bit को हम X की फॉर्मेट में रिप्रेजेंट करते हैं, हेक्साडेसिमल बोलते हैं. एक्सा में X आएगा, इसलिए 16-bit का रजिस्टर का रिप्रेजेंटेशन है. AX is a 16-bit accumulator है. AX contains internally two 8-bit registers. One is the AL, other one is the AH. Accumulator low, accumulator high, पूरा मिला के 16-bit हो गया. वो 16-bit को हम AX बोलते हैं. ये फंडामेंटल्स है. प्रगति फॉलोइंग, फारूक फॉलोइंग, नंदेश कृष्णा आर फॉलोइंग. So what is the meaning of this, my dear? Everybody try to understand what is the meaning of this. फटाफट बताइए. So if you see this particular point, if you see here, what is the difference between these? Anybody can tell me? What is the difference between these two? Can anybody tell me? What is the difference between these two instructions? Can anybody tell me? Shashank Balaji. See here, if you see the first one, if I am taking the memory location, so there is a base address. The base address is this. The base address is a 20-bit, suppose 10,000 at a distance of 0100. So this is the 0100. In 0100, I have a content called suppose some 44. Okay, so for this particular thing, what is going to happen? This, as your destination is a 8-bit register, so your here the AL is equal to 44. Okay, my dear. Suppose if you are representing AX, then automatically, then what happens to automatically consecutive the next memory location 0101, so that is 45. Suppose then automatically AH will be 45. So after the execution of this instruction, the result AL is equal to 44. After the execution of this instruction, the result will be 44 AL, 45 AH. So this is the reference. So this is what we call as direct addressing mode. Very good, very good, very good. 16-bit. Chal, thank you. This is what we call direct addressing mode. Next we'll go for number 4. Number 4. Number 4 is register indirect addressing mode, my dear. In register indirect addressing mode, what we are going to do? In register indirect addressing mode, what we are going to do? We are using the registers. That means, for example, if I am taking move SI, comma, or we can write load effective address like this. Load effective address SI, comma, 0100. Then I am writing move AL within the square brackets SI. Do you understand this? So this is different from this. यहाँ आपका effective address directly आ रहा है. Do you understand? आपका address field में directly effective address आ रहा है. CSE बच्चों try to understand. Here address field क्या है? Address field में register आ रहा है. लेकिन वो register का content जो कुछ है, that is not the operand. रजिस्टर में अंदर जो कुछ कंटेंट है, that is again an effective address. If you go to that effective address, आपको मिलेगा content. You understand? So SI is equal to 100. So that means what? This SI register, the SI register is equal to 0100. If you go to 0100 location, then in that location आपके पास कुछ content होगा. That content will go to this. This is what we call register indirect. All of you understood, my dear? Is it clear? 0100 में 16-bit का डाटा नहीं आ सकता. 0100 is a memory location can store 1 byte of the data only, my dear. Shashank Balaji, one memory location can store only 8 bit of the data. Digital में fundamental है. एक डिजिटल कैसा डिजाइन हो गया? इंटेल का जो कुछ प्रोसेसर्स है, 8085, 8086, 80186, 80286, 80386, 80486, 80x86. That 8 represents each memory location can store 8 bit of the data. So 44, 45, this is 8 bit, this is 8 bit. 0100 cannot store 40 total 16 bit. Got it? Very good, very good. मजा आ रहा है? Yes. Yes, sir. Yes or no? My dear students, up to this addressing modes, you are able to find in 8085 also. 8086 is having some extra addressing modes, my dear. What are the extra addressing mode? Let me come and discuss. Sorry. What are the extra addressing mode? Let me discuss here, my dear. See, what are the extra addressing mode? Up to this, we are also having in the 8085 having immediate register. These all we are having. So direct register, indirect we are having. In addition to this, we are having some extra. What is that extra? Please note down. The first addressing mode is extra addressing mode is based addressing mode. Based addressing mode, my dear. Based addressing mode means we are using some base effective address ke liye we are using some extra register BX or BP, my dear. That means I can write here move AL comma within the square brackets BX. This is what BX or BP. So this BX or BP are going to point to data segment. Next, sixth one, we are going to have the indexed addressing mode, my dear. We are going to have some indexed addressing mode. All of you are following, my dear? Any doubts here? In addition to this, BX, we can also represent some effective address like this. We can represent like this, effective address like this. That means अगर आपका effective address represent करने के लिए ये sufficient नहीं है, then what is the meaning of this? The contents of the BX and that is added with 0100. So this is going to be the net effective address, my dear. Try to understand this point. So this is going to be the effective address, my dear. Okay. In addition to effective address, we can add the BX. Similarly, indexed addressing mode. Indexed addressing mode, index registers like SI, DI, we can use it. That means if I am writing like this, move AL comma SI and 0100, suppose. That means what? The contents of the SI added to this effective address. So the net effective address will be what? The net effective address will be the contents of the BX plus this 0100. So this is going to be the net effective address, my dear. All of you following? This is what we call as their PC relative addressing mode. Do you understand? In our computer architecture, what you are doing, in addition to this particular PC, we are adding some relative address na. All of you are understanding, my dear? Everybody is following or not? Everybody is following or not? G. Next comes the sixth one. Based indexed relative addressing mode. Based indexed relative addressing mode. Based indexed relative addressing mode बोलो तो क्या है? In addition to this base plus index plus relative addressing mode. You got it, my dear? मजा आ रहा है? सर SI आना चाहिए. This is based indexed. Yeah, SI आ गया ना here. Sorry. Here SI add करना है. SI. Thank you. SI. This is what we call in our previous architecture. What we are calling effective address कैसा आ रहा है? Effective address के लिए SI का value आ रहा है. So this is what we call the offset 0100, and from this we are getting the SI. यहाँ क्या आ रहा है? Effective address. यहाँ से 0100 effective address आ रहा है. यहाँ से BX register आ रहा है. These are all different ways of accessing the memory. Different ways of accessing the memory, my dear. Clear है? मजा आ गया? But here देखो क्या आ रहा है? Here क्या क्या add हो रहा है? Here, in addition to SI, in addition to BX, in addition to that, we're also getting 0100. So that is the result, my dear. मजा आ गया? Because 8086 is a more sophisticated architecture ना, more sophisticated architecture, my dear. So extra content होगा based index relative addressing. Everything is clear, my dear? Okay. Still addressing modes are there. Suppose if you take 7th addressing mode, we can go for implied addressing mode. We have missed it. Here also we are having implied addressing mode, my dear. Here what are the implied addressing mode? NOP, HLT, decrement, rotate left, rotate carry, rotate left with carry, ROL, sorry. We are having some instructions, rotate left. These are on implied addressing mode. No operands, 7. Next, we are having string addressing mode. Of course, these are all extra. String addressing mode. String addressing mode, my dear, that is a move SB, store SB, string byte, scan SB. Next, we are having 9. Port addressing mode. Port addressing mode. See how the addressing modes are increasing. Port addressing mode के लिए IN in, ATH in port address, in accumulator, out accumulator, in and out instructions. In AL port address. So this is a port address, my dear. Out to the port from the 90H. So this is a port address. Are you following, my dear? Are you following? So कितना हो गया addressing modes का count देखा? 9 addressing modes. अगर आपने इसको split करो, suppose if you split this base addressing mode को फिर base relative addressing mode, some people will say base relative addressing mode, index relative addressing mode, ऐसा भी कर सकते हैं. Okay, लगभग 9 addressing modes आ गया, almost 9 addressing modes आ गया. All of you understood, my dear? All of you followed, my dear? That means in 8085 we got immediate, register, direct, register indirect, implied. Whereas in 8086 we are having immediate, register, direct, register indirect, based, indexed, based indexed, based indexed relative, and string, implied, and port addressing mode. देखो आर्किटेक्चर बदल गया. दिस इज 8-bit माइक्रोप्रोसेसर, दिस इज 16-bit माइक्रोप्रोसेसर. सो आर्किटेक्चर बदल गया, नंबर ऑफ एड्रेसिंग मोड्स भी बदल गया. मजा आ गया, माय डियर? एवरीबॉडी फॉलोइंग, माय डियर? चलो, नाउ प्रीवियसली हमने क्या क्या डिस्कस किया CO सब्जेक्ट में? बिफोर दैट आई हैव डिस्कस्ड ऑल दीज थिंग्स, राइट? So these are the addressing modes I have given, right? These are the addressing modes I have discussed, right? हमारा सिलेबस में क्या क्या डिस्कस किया? नॉन कंप्यूटेशनल, implied, immediate, register, register indirect, direct, indirect. Next, computable में auto increment, auto decrement, indexed mode, PC relative mode, PC register. Okay, got it, my dear? Now based on this, let us go for some question. See this, I think all of you are able to see this picture. See this particular picture, my dear. Based on this, now I am seeing one question, assignment question. See, there is a memory location, the memory starting address 200, 201, okay, 201, 202, next this is 399, this 400, 401, 500, 600. These are the memory locations. In that particular memory, we are having certain values, okay, and the first instruction is load to accumulator. This is a mode. This mode can be immediate, this mode can be register, this mode can be direct, this mode can be indirect, this mode can be relative, this mode can be indexed, this mode can be auto increment, this mode can be auto decrement. Okay, my dear? Chal. Now, try to understand. Just I am switching this. Just I want to move this side. Second. Yeah. Chal. Now, I want the content of the accumulator. First, let us start with this. Yeah, and in addition to this, we are having the PC value 200, R1 value 400. This some index register. We can take this index register. Our objective is what is the value of accumulator. Okay, na, my dear? Everybody, see the last column I have removed. Last column I have removed. I want to see the accumulator content for each and every addressing mode. Get ready. Please show me your thumbs up. This is an expected question. This is a way how a CO question can be formed. जितने लोग सेशन को देख रहे हैं मुझे एक बार थम्स अप दिखाइए, इस सेशन को लाइक कर दीजिए एंड प्लीज ट्राई टू आंसर दिस. This is what the actual cream. PC value 200. One of the register R1 is 400. This is suppose index register. You take this as an index register. XR बोलो तो index register. Index register is 100. Accumulator का value हम पता होना है. Now first thing is the first instruction takes 2 bytes. Why? Because the next instruction is very clearly given. So first instruction occupies how many memory location? 200 and 201, my dear. 200 and 201. Now please tell me, suppose if I am going for direct addressing mode, first one in the question, direct addressing mode. Okay na? So if I am going for direct addressing mode, what is the answer? You must tell me. Chalo. Please tell me, if I am going for direct addressing mode, what is the effective address? Direct addressing mode means what? The instruction will be what? Direct addressing mode, load accumulator 500, load accumulator 500, yes or not? In direct addressing mode, how the instruction will be? First of all, if I am taking direct addressing mode, what is the instruction? Load accumulator, whatever may be the language, load accumulator 500. Now tell me, what is the effective address and what is the accumulator value that I want? In direct addressing mode, load accumulator 500. Suppose what is this 500? This 500 is going to be the effective address or not? Please answer my question. If I am writing the instruction like this, load accumulator with 500. But what I mentioned is a direct addressing mode. In direct addressing mode, whatever I am giving, what is that? So if I am taking this as an opcode, of course opcode is also having the mode. That means what is this instruction set I am mentioning here? Try to understand. The instruction ka format kaisa hoga? The instruction ka format, this is opcode and this is the mode and this is what we call operand. Now tell me, or this is what we call effective address. This is what we call address field. This is what we call address field. So what is the opcode? The opcode I am taking is load. Whatever may be the processor. If it is a 8085, it is LDA. If it is a 8086, some other format. If it is a 80, some other format. But the basic agenda is load. And what is the mode I am using? The mode I am using is a direct. In direct mode, what is the effective address here? This field contains what? This field contains directly effective address. So what is the effective address, my dear? The 500 na? Yes. So the effective address is 500. And what is the content of the accumulator? Please tell me. What is the content of the accumulator? Please tell me. What is the content of the accumulator? Please tell me. What is the content of accumulator? Please tell me, my dear. I want the content of accumulator. Please answer. This 500 is the memory location. If you go to the 500 memory location, in the 500 memory location, what is the content present? Effective address. See, this is the instruction, my dear. Instruction, first instruction is taking the 2 bytes. First instruction is taking the 2 bytes. Next instruction starts. That means in the immediate addressing, in the direct addressing mode, what is the syntax? In the direct addressing mode, load accumulator with a 500H. So this 500H is the effective address. Effective address is 500. If I go to the 500, what is present? 800. So the accumulator value kitna hai? Accumulator value kitna hoga, my dear? 800 hoga. Do you understand, my dear? Do you understand or not? Is it clear? Maza aa gaya? Chalo. Next, second will go for immediate. Second, we are going for immediate. If I am going for immediate, second, if I am going for immediate addressing mode, in immediate addressing mode, what is the syntax? If you go for immediate addressing mode, what is the syntax? That means load instruction only, but whatever that instruction that you are giving, load accumulator 500. This is the instruction, immediate addressing mode. But in immediate addressing mode, what is the syntax? In immediate addressing mode, this is the opcode. This is a mode. Yeah. So this is our opcode. This is our mode. This is our address field. Okay. So here, opcode is what? Load. What is the mode? The mode is immediate. Once you mention the immediate, whatever is present here, what is the address present? That is a 500. Now tell me, what is the effective address? What is the accumulator? Please tell me. I want the answer for this. Here, address is what now? So here, whatever you are mentioning, if you are mentioning the immediate address, this 500 in the instruction, jo kuch bhi present hai, that is going to be taken as what? That is going to be taken as what? Accumulator is loaded with what? I mean, the meaning of this is what? The meaning of this is LXI, okay na? Or LXI A comma, suppose like 500. Suppose you try to understand, this is one address LXI A. That means whatever that comes after the comma, that means whatever that comes after the comma. Yes. Accumulator is 500, my dear. So accumulator is 500 means, but what is the effective address? The effective address is the next instruction na. See, this is our opcode, and whatever is there, this is 500. This 500 is present in where? This 500 is present in 201 location na. So this 201 is going to become the effective address, and whatever that 500 is there, that will go to accumulator. So here the effective address is equal to 201 and the accumulator will become how much? 500. Yes or not? Effective address will be 201, my dear. Why? Because LD load accumulator is a first, that is the opcode 200. 201 contains the 500. So 201 is the effective address. In that effective address 500 is there. That 500 is going to be taken to accumulator. Do you understand, my dear? So that's why, see here. So the effective address is 201 and the contents of the accumulator is 500, my dear. Followed? Are you followed or not? Clear? Next, if I am going for the indirect addressing mode, next, if I am going for the indirect addressing mode, next one, indirect. See here, in indirect kya hoga? That means in indirect, whatever that you are mentioning, whatever that you are mentioning, that is not going to be the effective address. Okay, so directly I will move this. So if you see here, confused. Yeah, if you are going for the instruction called indirect addressing, indirect addressing means what? Load accumulator 500. Is this 500 is the direct address? No. If you go to the 500, in that 500 you are having 800. This 800 is going to be the effective address, na? Why? Because whatever that contains after the opcode, that is not a direct. In indirect addressing mode, whatever that comes after the opcode, that is not the direct, that is the indirect. So what is the indirect? That 500. If you go to the 500, in the 500 you're having 800. So this 800 is going to be the effective address or not? Yes. 800 is effective address. The contents of the 800 is 300. So that 300 is going to be the accumulator or not? Are you following, my dear? 500 is not the direct address. 500 is having another effective address. That is the meaning of this indirect addressing mode. So if I am mentioning the 500, that 500 is having, sir, in immediate mode, if 500 was present in 2 locations, then what will be the effective address? In immediate mode, if 500 was present in second location means 201. What will be the effective address? This is the effective address. This will be the effective address now, my dear. It is present in this 201. It is present in the 201. So this is going to be the effective address. Why? Because immediate operands, whatever that content is, that itself is a operand, right? That 500 is a operand. Got it? 201 is the immediate location. 201 is the next location. 200, 201. So this is the opcode. Opcode after whatever is there, that is effective address. In that effective address, the content 500 is there. That 500 goes to the accumulator. Got it? If you write a table, 200 is the opcode. 201 is the next location. In the 201, we are having the 500. I mean to say, what is the meaning of this? If I want to say like this, see, this is my 200. This is the 201. Okay. What is the immediate addressing mode syntax? Suppose LXI A, okay, na, or load immediate is a syntax. As you are talking with microprocessor, we'll go like this. Load immediate. So load immediate is the instruction opcode with what? Load immediate with 500. Okay. So 200 में opcode होगा. 200 में opcode होगा. 201 में क्या है? 500. That means load immediate A comma suppose 500. This is the point. Or you take it as move immediate, beta. If you are confused, you take it as move immediate, enough. Suppose you take it as move immediate over story. Move immediate A comma 500. So move immediate A is present in which location? 200 location. The next consecutive memory location is 201. In the 201 we are having 500. Maza aa gaya? If you are confused, you take move immediate. Why you are worrying about the load? Load and move almost the same. Got it? Move is a copy instruction. Load means we are taking from the memory. So move immediate A comma 500. But whatever you are mentioned I here, अगर I mention किया comma के बाद जो कुछ भी हो, that is taken as a data. Actually 500 is address. But इधर आपने I mention किया, अगर एक बार immediate mention किया, क्या होगा? That is a address. That is a data. Sorry. Immediate addressing mode में जो कुछ भी comma के पास, comma के next जो कुछ भी है, that is a data. Got it? मजा आ गया? So 200, 201. चलो next. अगर आप confused हुए तो move instruction लिए. Next. Indirect addressing mode क्या है? Move immediate. Indirect addressing mode होता है move A comma 500 square brackets. But ये 500 direct है? नहीं. Direct नहीं है. 500 contains some effective address. You try to understand this. So we can take like this. So it is what? Indirect addressing. Indirect address mode बोलो तो क्या है? Move A with what? 500? No. Again square brackets. 500 is not direct. 500 contains something. 800. That 800 contains something. 300. So 800 is going to be the effective address. 300 is going to be the data. मजा आ गया? Everybody following? Everybody following my dear? मजा आ रहा है? चलो. Please show me the thumbs up, beta. If you are understanding, if you are confused with load, please take another instruction, any instruction. I'm not talking about load, you take move. We are not specific to microprocessor here. This question is not specific to any microprocessor. चलो. Next comes the relative address. Relative address बोलो तो क्या है? Relative address बोलो तो क्या है? Relative address बोलो तो PC relative. In our CO, we are having the PC relative. PC relative बोलो तो क्या है? When you are actually you are here, okay, now you are the first instruction. When you are here, what is the PC value? Please tell me. When you are here, what is the PC value? PC always points to the next instruction. First instruction occupies 2 locations. PC क्या है? PC very clearly given. Actually, before starting the program, PC was 200. But when you are answering this particular instruction, what is the PC? PC will be 202 na? Got it? PC is 202 or not? PC relative. What is the relative? What is the address now? This is 500. So offset is a 500. So offset we have to add na. Effective address offset we have to add na. So 202 plus 500. Okay? जो कुछ effective address मैंने instructions में दे रहा हूं, this effective address मैं instruction में दे रहा हूं. So PC relative address में क्या होगा? That means I am writing here PC relative addressing बोलो तो move accumulator with PC and 500. That's the meaning. PC बोलो तो कितना है? PC is already 202, effective address 500. So कितना हो गया? Total मिला के 702 हो गया. So if I am taking PC relative addressing mode 702 हो गया effective address. 702 में क्या है? 325 है. So 325 आएगा. मजा आ रहा है? All of you following Gupta? जितने लोग सेशन को देख रहे हैं, try to understand the things. Okay? Clear? Next, index addressing mode. Index addressing mode बोलो तो क्या है? Index addressing mode में in addition to your offset, effective address कितना है? 500. Effective address कितना है? 500 my dear. Effective address actually 500 है. Load accumulator with 500. 500 is the address. Okay ना? So in addition to this 500, index register कितना है? 100. So 500 plus 100. Am I right? So 500 plus 100, 600 होगा. In 600, what is the content present? 900 is present. So 900 आएगा इधर. Got it? Next, in register addressing mode क्या होगा? In register addressing mode, are you going to take anything as effective address? No. In register addressing mode, we are not bothering about the memory, my dear. So we will take this 500. We will take the register directly. Register addressing mode बोलते तो register का value. So register का value जो है 400. So that 400 is going to be loaded. In register addressing mode, the content of the register is copied to the accumulator. Content of the register is copied to the accumulator. We are nowhere concerned with the memory. That's why in register addressing mode, no memory access. No memory access. Got it? Next. Register indirect. Register indirect बोलो तो direct की opposite. Direct का opposite. That means जो कुछ content of the register content कितना है? 400. The 400 is acting like an effective address. Okay. So indirect 400. In 400 what we have? 700. In 400 what we have? So please go through this. You will have some idea. Okay. Auto increment. Register को increment करो. Auto increment करो. Auto increment करो 401. Auto decrement करो 399. 401 में क्या है? 125. All of you followed? Chalo. Now based on this, I have formed one question. Try to answer this question. Try to answer this question. First, try to answer this question. Try to answer this question, my dear. An instruction is stored at location 500. So there is a location called 500. So 500. An instruction is stored at location 500 with its address field at location 501. This is opcode and it is address field or operand. The address field has a value 100. So what is address field? That 501 is having a value. This 501 is having a value 100. Got it? 501 has a value 100. A processor register contains the number, register number is 150. Register contains 150. Evaluate the effective address if the addressing mode is direct. The first one is a direct addressing mode. What is effective address? Please tell me. Second one is the PC relative. What is the effective address? Tell me. How to calculate the effective address in all these addressing modes. Third one is the register indirect. Register indirect. What is the effective address? Tell me. First one is the direct. Second one is the PC relative. I am expecting the answer. Fatafat, tell me. An instruction is stored location 500 with its address field at location 501. An instruction is stored at location 500 with its address field at location 501. The address field has a value 100. A processor register contains the number 150. Evaluate the effective address if addressing mode is dash. In direct addressing mode, what is the syntax? What will write, my dear? Load accumulator will mention effective address directly. Yes or not? Load accumulator directly will mention. So we'll write load accumulator, comma, directly what you will mention here? Yes, in direct addressing mode, directly will mention the effective address. What is the effective address? Where is the operand is present? 100. 100 is present at weight 501. So what you want to upload accumulator in direct addressing mode, its operand, that is a 501, right? Yes or not? Yes, the 501. That means the contents of the 501 are copied to accumulator. Is it clear, my dear? Chalo, second one. PC relative addressing mode. PC relative addressing mode. PC relative addressing mode कितना होगा? When you are at 500, what is the program counter value? That means load accumulator with what? PC and effective address. That is a how much? How much, my dear? PC and relative value. So what is the value? PC value कितना है? When you are at 500, the PC value कितना होगा? So this is a one instruction. The next instruction starts from 502 na? The next instruction starts from 502. So when you are executing this instruction, the next instruction starts from 502. So PC is equal to 502 plus relative. What is the relative value? That is the next address. Whatever is present in the instruction, that itself is taken as address. So 502 plus 100. So that is going to become 602. 602 is the answer. Got it or not? Any doubts? Any doubt, my dear? Here what is asking? It's asking PC relative. That means your address field is already 100. In addition to that, you have to add the PC. That's it. Register indirect mode means what? The register. The register itself is showing the effective address. Yes or not? So the 3 will be 150 na. In register indirect addressing mode, the register value will take it as effective address na, keval effective address. Third one is 150, my dear. Now how 100? The register value is 150. The register contains 150. So the register is treated as the, that means we are going to take like this. Move a comma within the square brackets register. So what is the register? The register value is how much? 150. That's it. So that is the effective address. In PC relative, what we are going to do? We are going to add this effective address. So this is the operand field, right? It is having a value of 100. The address field is having a value of 100. Got it, all of you? Maza aa gaya? All of you followed? Anybody? Any doubt you can ask me. Chalo. So people were asking this as a doubt. Please try to answer this. DPP2 में doubts था. DPP2 में कुछ doubts है. वो doubts के लिए मैंने collection कर दिया. Somebody has kept the question number 2 as a doubt. Question number 2 as a doubt. Can you tell me? Consider a digital computer which supports only 2 address instructions, each with 16 bits. So this is the 2 address instruction. 2 address instruction बोले तो क्या होगा? So this is my opcode. This is operand 1. This is my opcode. This is my address 1. This is my address 2. 2 address instructions, each with 16 bits. If address length is 6 bits, so this is 6, this is 6. Then the maximum, the total length kitna hai? Total length is 16 bits. So 6 plus 6, 12, this is 4. So how many number of instructions maximum? So opcode size of opcode is 4. So the maximum instructions are 2 power 4. 2 power 4. 16 is the maxima. So maximum is 16. Maximum is 16. Minimum is 1. Maximum is 16 and minimum is 1, my dear. Yeah, I have corrected it. Corrected. The DPP is corrected, my dear. Just try to have an idea of this PC relative addressing mode very clearly, my dear. PC relative addressing mode पर ध्यान रखो. PC relative addressing mode पर PC value is going to be added. PC value is going to be added. Why? Because while you are executing this instruction itself, the PC value is updated. And जो कुछ आपका instruction में address है effective address, आपका effective address इधर है, है ना? Next field में है. Thank you. चलो आज का सेशन मैं end करता हूँ. I feel all of you followed the session clearly. Okay. इतना elaboratively मैंने addressing modes discuss किया. In fact, there is no need of discussing 8085, 8086 addressing modes, but clarity के लिए मैंने discuss किया. Okay, so please try to follow these particular addressing modes in a practicing way. Try to practice more questions. At the end of this session, I'm forwarding the DPP. In the DPP, you can find more number of questions. Okay, chalo, love you all. Take care. Bye bye.